Hey guys, today for our first bit of review, we are going to be going through the previous released free response questions. So, your final exam this year is only 2 free response questions. So, I want us to go through what they have done in the past so that you can see what type of questions to expect and you can see what topics come up the most. We will be discussing these in a Zoom class at the end of this week, so I will keep you posted about that in the Google Classroom. Make sure you fill out what time works best for you. But I do want you guys to know that we are all filling this out on the exact same Google Docs, so you don't have to make a copy of your own. That way you can see what each of these questions entails without having to go through all 60 of them all by yourself. So I'm going to go through all of 2019 just so you can see what I'm looking for, and then I'm going to ask you guys to each pick 2 years, and if you will just pick 2 years that somebody hasn't already done, and if you will fill those in, and then at the end of the week we'll be able to see everybody's answers for all basically the past decade. So starting with question 1 in the 2019 test. It says the sizes in square feet of the 20 rooms in a student residence hall in a certain university are summarized in the following histogram. Based on the histogram, write a few sentences describing the distribution of room size in the residence hall. We all know anytime you see the phrase describe the distribution, that means do socks. B says summary statistics for the size given are in the following table. And it says, determine where there are potential outliers in the data and use the following grid to sketch a box plot. So we need to know how to do the outlier test. And we need to know how to draw a box plot. Oops, I guess she makes it a little wider. Alright, and then C says, what characteristic of the shape of the distribution of room size is apparent from the histogram but not from the box plot? So I need you to be able to tell the difference between a histogram and a box plot. So alright, and that will get you all of the parts for question 1. I'm going to have to make all these wider. Give me a second. So keep scrolling to question 2, which says, researchers are investigating the effectiveness of using a fungus to control the spread of an insect that destroys trees. The researchers will create 4 different concentrations of fungus mixtures, 0 milliliters per liter, 1.25, 2.5, and 3.75. An equal number of the insects will be placed in the 20 individual containers. The group of insects in each container will be sprayed with one of the 4 mixtures, and the researchers will record the number of insects that are still alive in each container 1 week after spraying. Identify the treatments, experimental units, and response variable of an experiment. So I am just going to put, you need to know, honestly, I don't want to put parts of an experiment because that's something completely different. I'll just write these things. So you need to know what all 3 of those things are, obviously in context. I swear, please, I'm going to say in context 1,000 times before you take this test. Put it in context. It does not want the vocabulary definition of those 3 things. It wants them in that experiment situation. Okay. B says, does the experiment have a control group? So you need to know what a control group is in order to answer that question. And C says, describe how the treatments can be randomly assigned to the experimental unit so that each treatment has the same number of units. So you need to understand how randomization works. And I would also keep in mind experimental design when you're doing this. So I'm going to say random assignment / we'll say and. Experimental design. So that you can set it up. So those are what you need for question 2. Let's see if I can cut this a little bit. All right. Question 3. And you're not actually solving these yet. Right now we're just going through and seeing the things you need to know how to do in order to solve them. 3 says, a medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The response was categorized as never, sometimes, or always. The relative frequency of each category is shown in the table. Remember, relative frequency and frequency are not the same thing. Relative frequency is the percent, frequency is the count. Okay. A says, of the person surveyed to be selected at random, what is the probability the person will be blah, blah, blah? What is the probability of that? And what is the probability of that? So we're going to say letter A, you need to know how to do probability. For letter B, for the people surveyed, are the events of a person who responds never and being independent. So you need to know the test for independence. Probably should put bullet points on these. That would make life probably go a little bit easier. I'm not going to do that now because it'll waste time on the video, but when you look at it, there will be bullet points here. All right. C says, assume that in a large population, the probability a person will always take medicine as prescribed is 0.54. If 5 people are selected at random, what is the probability that at least 4 of the people will always take medicine as prescribed? So anytime you see the at least, remember that's when you do 1 minus total. You also could do binom CDF when you're doing this. So either one of those is fine. I'm going to put binom CDF down. But you don't have to use binom CDF. You could just use the fact that it says at least. Both will get you the correct answer. All right. Number 4 says, tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. Gonna say kochia. A type of plant that turns into tumbleweed at the end of the summer is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. Scientists are concerned that kochia plants are becoming resistant to the most commonly used herbicide. Oh, these words. Glyphosate. I'm gonna go with glyphosate. In 2014, 19.7% of 61 randomly selected kochia plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected kochia plants were resistant to glyphosate. So, if you don't get mixed up and tongue-tied just by reading that, the last little bit pretty much tells you what you're going to do without all that information. It says, do the data provide convincing statistical evidence? There's a really good key phrase there, convincing statistical evidence that the level of alpha, that's the alpha symbol, equals 0.05, that there has been an increase in the proportion of all kochia plants that are resistant to glyphosate. So this lets you know, that last little bit right there lets you know that this is a statistical inference problem. Statistical inference is what we've been doing basically since we began out of school. Every single lesson I've given you online has been statistical inference. This particular one is proportion because it says has been an increase in the proportion. So there's a good way to know which one to use. I know that you have proportion, you have mean, you have matched pairs. So there's a lot of ones. So not only is recognizing that a problem is statistical inference, is then deciding which one you're going to use. We'll get this in more detail, but if you look in the very back of your little folder I gave you that has all your portfolio stuff in it, in the very, very, very back, there is a huge chart that says statistical inference, and it breaks down every single one, including ones that we did not have to cover because the school year ended early. But this is a statistical inference proportion problem. Notice in here, it does not once say state the null and alternate, state the condition, state the p-value. It does tell you that your alpha is 0.05. It doesn't tell you any of those things, but those are all the things you have to do. So there's an example of what one of these looks like without all of the fill in the blanks that I give you, all of the breaking down, state the null, state the condition, state this. You will not see one of those. It is going to look like this one. So that is actually all for number 4. Like, we know that that is a whole lot of parts. Like, there may not be a B, C, and D listed, but we know that there's a B, C, D involved. All right, number 5 says, a company that manufactures smartphones developed a new battery that has longer lifespan than that of a traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal with a mean of 30 months and a standard deviation of 8 months. So we already know right there, normal distribution's involved when it tells you that. For the price of $50, the company offers a 2-year warranty of the new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months of the date of purchase. So A says, in how many months of the date of purchase is it expected that 25% of the batteries will no longer work? This is a normal distribution problem, which we already knew that. In this particular one, in part A, you would need to know how to do the normal CDF or invalid norm, depending on how it's asked. This one gives you the percent, so in this particular one is invalid norm. If it doesn't give you the percent, you obviously use normal CDF. All right. B says, suppose one customer who purchases a warranty is selected at random. What's the probability that the customer selected will require a replacement within 24 months from the date of purchase because the battery no longer works? This is a Z-score question. So you would find the Z-score of that particular person. Be careful because it says probability. A lot of students are always tempted to say, oh, this is a probability problem. Yeah, it kind of is, but you wouldn't use the probability rules to solve this. You're going to use the Z-score. All right, and C says, the company has a gain of $50 for each customer who purchases the warranty but does not require the replacement. The company has a loss of $150 for each customer who purchases a warranty and does require the replacement. What is the expected value of the gain for the company? This one straight up says it. It is expected value. All right, so at the bottom of this chart, I'm actually going to add in a giant list of all the things that we have covered, at least to the best of my knowledge. I guarantee something's going to get left off. But I'm going to do the best I can to put all of the different topics so that when you're looking through, you can be like, man, I have no idea what to call this. Oh, yeah, that's what it was. So that may be a little bit helpful. Also, of course, you have your notes and your textbook, all sorts of things to go through. But this is what I mean when I say how to fill them out. You will notice as you're going through these that, yes, there are a total of 6 questions. But the 6th one is different. It's actually worth more points. It is one of those like investigative tasks, and they are not giving you an investigative task this year. They are just giving you 2 free response questions. So I'm not even going to have you bother going through the investigative task because they are far more difficult, and we're not going to bother with them since you're not going to be tested on one of them. So real quick before this video is over, I do want to show you how to get there. So I'm actually going to bring this up into the big screen. There we go. So I went and typed in 2019, but if I just don't type a year at all, the very first one says AP Statistics Exam Free Response Questions. So go there. And you will notice all of them are there. There's 2018, 2017, 2016, 2015. You get the point. Let's look at what each thing gives you. In this link here, it gives you just the questions. Here it gives you all the answers and how they are scored. Here, they actually picked responses from 6 different kids that last year who did it and showed you why they got the score that they got, and then, of course, the distributions. So where I want you to go, I'm just going to click on 18 real quick. Click on the questions. You are going to have to scroll past all of your formulas, so you won't need any of those to do what we're doing, and then go to the questions. Okay? Now, let's say you get to a question and you just have absolutely no clue how to solve it. In that case, I want you to go to the scoring guidelines. So you already know what the question's asking, but you're like, yeah, I have no idea how to do that. I don't know what I need to know how to do that. Go through. It tells you what they wanted you to know about this question. It tells you the solution of how they got it, and then it goes into exact detail of what you needed to get full credit. Remember, our stuff is graded as either E, P, or I. E is essentially correct, P is partially correct, and I is incorrect. So go through and make sure that you have all of those things if you need to. Okay? This is available for every year the AP exam has ever been given, just so you know. So you can do way more than I'm asking you. I just want you guys to do 2 years. And we will, like I said, talk about this in our Zoom class. If you have any questions, though, please feel free to email me.